Everyone, I welcome to you Thermo Green Innovation YouTube channel, a channel to share information on thermal system advancement with green energy integration. I am Dr. Devendra Raut, PhD in thermal energy systems. Today's topic of discussion is thermal energy storage. To understand thermal energy storage, we should understand current energy scenario. As per the current energy scenario, most of the energy is coming from the oil, coal, gases, hydropower, or we can say the conventional source of energy. And the result of which is that there is a continuous decrease in the fossil fuel residuals, increase in fossil fuel prices, increase in CO2 emissions, and thus global warming is a major threat. Considering all this scenario, we can say that the world will need a transition toward more sustainable and renewable energy system. If this scenario continues, there will be definitely energy crisis by 2014. So what is the solution for this? Solution is solar energy. Looking at this, nowadays government is also adding some mandate for integration of solar energy applications for various applications. Like Government of India embarks on the solar energy journey and allotted a major fund in the budget 2022-2023. As we know that, so the sun is the ultimate source of energy for our planet. Harnessing its power and is critical to the future of human civilization. As all of you know that solar energy can be availed in two forms. First is a solar PV, in which we can convert the solar radiations into electricity. Another is solar thermal, where we use the heat content of solar radiations. So now we understand we can harness the solar energy in two forms, electricity and heat. But what about the storage? Conventional electrical batteries are there to store solar energy in form of electrical energy form. But what about the heat storage? When we store a heat, that device is called as a thermal energy storage. So thermal energy storage is nowadays a very hot topic, and everybody is talking about this because it has a great potential. So we can see what is thermal energy storage. I have listed some Government of India's action plan toward thermal energy storage, that they are in developing more research and development labs in India for thermal energy storage. So just consider a scenario where cell radiations are falling on solar thermal collector, and the output of the solar thermal collector is connected to thermal energy storage. The hot fluid loses its heat when it's come in contact with thermal energy storage. What is in then thermal energy storage? It absorbs the heat from the hot water. And the question is, what is there? So there are multiple ways. Like thermal energy storage can be a sensible energy storage, it can be a latent energy storage, and it can be a chemical energy storage. When we talk about sensible, the hot water storage using insulated tank is the very good example, which we use in integration with solar thermal collector. But the problem with the sensible thermal energy storage, it's its higher volume. It requires large volume when we have to store large amount of the heat. To address this issue, latent heat energy comes into the picture. The storage of heat energy using phase change material requires very small volume, almost 1/3 of the sensible heat storage, and it can deliver the heat at constant flux. It can store the heat at constant temperature as well. So thus we can say that thermal energy storage is a nowadays hot topic for energy storage. And another form of thermal energy storage is chemical energy storage. If we talk about the relevance and the current trend in thermal energy storage, if we visit the newspapers, we can see that thermal energy storage beats hydrogen electrification on industrial cost. A Germany study shows that thermal energy storage can be economical as well as technical advantages over the other energy storage techniques. The other trend is showing that in upcoming years there is a great boom in thermal energy storage sector. Now understand the architecture of thermal energy storage using phase change material. Consider a tank filled with a PCM in which a hot fluid passage is embedded, like a tube of copper is embedded in PCM. The hot fluid will go through the copper tube and the PCM at the lower temperature will receive the heat from hot fluid. If we observe the temperature curve of the PCM, we can observe that at the very first phase, that is the line 1, there is a continuous rise in the temperature with the time. This range is called sensible heating of PCM before melting. Line 2 indicates the phase change phenomena at constant temperature, and the temperature will be equal to melting temperature. Till the complete PCM gets melt, there is no rise in the temperature. After that, there is a rise in temperature again. The line thirds indicate sensible heating after melting process. In this way, the temperature of PCM evolves over the time. The area under the phase change process indicates total latent heat storage. If we want to quantify how much energy is stored in a thermal energy storage, we can say the energy storage is equal to latent heat. So the area under the shaded region will be the capacity of thermal energy storage. In this way, the thermal energy storage using phase change material works, whether it could be hot or it could be cold thermal energy. All about from my side for thermal energy storage. If you want to learn more about thermal energy storage and its development, please subscribe my YouTube channel. I will continue update relevant videos on my channel. Thank you.